Alright, in this video we're going to go over how to solve a programming problem like this one. Here's problem 1. How to calculate a home's value. Housing economists have long used a home price-rent ratio as one way to gauge whether or not home prices are inflated or undervalued. Hence, a housing PE. The use of a price-rent ratio is analogous to employing a price-earnings ratio for stocks. When a stock price is high and its earnings per share relatively low, the PE is high. A high PE often indicates that the stock is too expensive and that the share price is headed for a drop. What someone is willing to pay to rent a place is that home's earnings. And just as in the stock market, a high home price related to the rental earnings means home values will probably drop. For a specific look at how a home's PE is determined, let's consider a home that is listed for either rent or sale in suburban Chicago. The home has been rented for the past 3 years for $1,600 per month, so that is $19,200 per year. It is currently listed for sale at $400,000. Dividing the price by the total annual rent of $19,200 gives a housing PE of 20.83. According to moodyseconomy.com, the long-run average housing PE is 16, so a PE of 20.83 suggests that this home may be somewhat overpriced. For this programming project, you will read in a list of housing prices and how much each house is rented for that are found in the attached housing prices.txt file. Integer, housing price, housing rent. Where the first value on each line is the price of the home, and the second number on each line is the price that this home currently rents for per month. Read these numbers in from the file into two separate arrays of size 100, since there are 100 home price rents in the file. Do this part in your main method. Then use a for loop to loop through the arrays, and for each pair of values, send them into a method that you will write called getHousingPE. Your method will have two parameters, the price of the home and the currently monthly rate of the home. Your method will calculate and then return the home's housing PE. Check each home's returned PE value, and if the PE value is greater than 16, you should write to the output housing and the index number plus 1 is somewhat overpriced, where number is the number of the house in the file, 1 through 100. If the PE is greater than 19, then you should write to the output house number is way overpriced. If the PE is less than 12, then you should write to the output house number might be a good deal. And if the PE is less than 9, you should write by house number it is a deal. If the PE is between 12 and 16, then output house number is average. Alright. The first step in completing a problem like this is to download that text file. Here's our text file. In previous videos, I've shown how to download this text file into the correct location in your project folder outside of your source folder in Eclipse. In our text file, we have an integer, which is the housing price, and then another integer, which is the housing's monthly rent. There are 100 housing records inside of this file. As you can see, I've already added my name and information about this program, the date, and then a rough algorithm of the steps we're going to use to solve this problem. Step 1 would be read the data from the file into two arrays of appropriate data type. Step 2, close the file. Step 3, iterate through the data structure and calculate the housing PE for every house, and output this housing PE and output the correct statement based upon that PE. Alright, we've already created our class, appropriately named with a capital letter. And now we're going to create some variables to store the data from the file. Since we're going to be storing two integers, it makes sense to have two integer arrays. Therefore, I've created two integer arrays of size 100. Moving on to step 1, now let's read data from the file into our two arrays of appropriate data type. Remember that we can copy and paste this code from a previous program and then change the code so that it fits our program. So our file is not called car.mpg.txt. Our file is called housingpricesandrent.txt. Remember, you can copy and paste the file name in there and you'll be sure to spell it correctly. Then we create our scanner object. We set it equal to null outside of our try-catch block. It opens up our file, and if the file has a problem, it catches that file not found exception, prints out our error message, a stack trace, and stops our program from running. We also have our system out println file open, so if we make it here in our code, we know we successfully jumped around the catch block and our file has been successfully opened. I then created a count variable and set it equal to 0, and then I have my while loop which checks my file if there is more input. I know that there is 100 houses in my file, so I could have replaced this with a for loop, but I'll just leave it how it is. Alright, now the name of my first array is house price. So I'll read that data of the house price into that array. Remember, order is important. The house price is first in our text file, so I'm making sure to read that data in first. The second data item in my file is our house rent. And then I move on to the next record. This will iterate 100 times. Now it's red over here because I'm asking my input for a double, but I'm reading them into integer arrays. So I need to make it read in an integer and not a double so that we don't have a type mismatch. Remember that a double does not fit inside of an int. 8 bytes does not fit inside of 4 bytes. Now we should test our code that we've read this data incorrectly, and let's copy and paste a for loop here to iterate through our arrays and print them out. Alright, here's my for loop that I've copy and pasted, and I'm going to iterate not my mpg.length, but my array's name.length. Alright, let's just do a couple of system out print lines to output our data to make sure we're reading it from the file correctly. Alright, and if you want your output to have a comma, make sure you concatenate that comma in there. Alright, go ahead and run your code and make sure. If when you're testing your code, you see something like this print out, no such element exception, sometimes this is caused by our text file not being correct. In your text file, if you have an extra line in here where there's no integer and integer, that's when it fails. So if you backspace and get rid of that extra line, and then Control S and save your file, and then run your code, you'll see that you won't get that no such element exception. Alright, we've read our data into our arrays, and we've tested them. Now we need to move on in our problem to our second step. We're going to iterate through the data structure and calculate the housing PE for every house and output this housing PE and output the correct statement based upon that PE. Alright. And don't forget to close your file. Here's our for loop, and in it I'm printing out right now just the housing price and rent. But I want to print out the housing PE and the index of that house. But the indices that I want to print out are 1 through 100. So I need to add 1 to my I value when I print it out so that it will print correctly. Then I want to print a statement based upon that PE. So I need to calculate that PE for every house. So I'm going to use a variable called PE, and I'm going to make a new method called calculatePE. In order for this method to know what the PE is for this certain house, it'll have to know the house's price and that current house's rent. Let's make a method. So let's make a method to calculate the PE for a single price of a house and a single rent for a single house. Remember that to calculate the PE, we need to divide the price by the total annual rent. Alright, that seems simple enough, but remember to always double check. Order of operations, yep, I got my parentheses, and int math. I am performing integer math here. I'll get the wrong PEs with no decimal places. But if I change my 12 to a 12.0, now I have an int divided by a double, and I'll get the right answer. Now let's run our code, calling that function calculate PE for each house in our array at the I index and each rent in our array at the I index. So this is for each record or each house. We're going to calculate its PE. We'll then print out its index number plus 1, a tab, and then that corresponding PE. Now we need to not just print out this PE, we need to figure out, alright, I've copy and pasted these directions from our programming problem, and I've implemented these steps. First we want to check if the PE value is greater than 16 and write house number is somewhat overpriced, where the pound symbol is the number of the house in the file 1 through 100. So I went ahead and did that. If PE is greater than 16, house, and then that index number plus 1 is somewhat overpriced. If the PE was greater than 19, then I outputted way overpriced. If the PE is less than 12, then we wrote might be a good deal. If the PE was less than 9, we put by house pound symbol, it's a good deal. If the PE is between 12 and 16, greater than and equal to 12, and the PE is less than or equal to 16, then we output house is average. Now this may seem like it's a good implementation of these directions, but this isn't going to give us our desired output. And you have to do a little pen and paper running through of your algorithm to see this, or even just run your code. You're going to see some crazy stuff print out. It's saying that some of the houses are somewhat way overpriced and way overpriced. Why is it doing these multiple statements? To see why this code fails, let's plug in a number for PE. Let's say that PE is, let's say 11. 11 is not greater than 16, and it skips that next statement. 11 is not greater than 19, and it skips that next statement. It then checks if 11 is less than 12, and it outputs might be a good deal. It then checks if 11 is less than 9, and that's not true. It then checks if 11 was greater than 12 or less than 16. That one seemed to work okay. It did only output that one line. Now let's try a big number like 28. Some of my houses did have that PE. 28 is greater than 16, and it outputs somewhat overpriced. But then, since these two branching statements are not connected, it comes down here and checks this one. When I have a big number, like 28, this one will be true, and this one will be true. Now which one should be true? Only this one. So, to make these branching statements connected, you have to connect them with an else part of your if. That way, only a single branch will be chosen. Now let's run that number 28 through our algorithm again. 28 is greater than 16, and it prints out somewhat overpriced. But we know that it should have printed out, since it's greater than 19, it should have printed out way overpriced. The order of these statements now matters. We should check if it's 19 first, and then 16 second. By having our statements check the greatest values to the least values, we'll output the correct statements. So if I plug in a 28, it will be true, it'll say it's way overpriced, and then it'll skip all the other else ifs and come back to check the next house. So I need to order my statements from checking the greatest amount to checking the least amount. So now I've reordered my statements to check greater than 19, then check greater than 16, then check the range between 12 and 16, then check less than 12, and then check less than 9. Wait a second, when I'm checking less than, I need to check the least amount first. So I need to reorder my least statements to go from least, checking the least amount, to checking the greatest least amount. Because if I run let's say a 7 through our code, if I had these in the other order, it would say yes, might be a good deal, but a 7 should print out it is a deal. So when checking greater than, I need to go from highest to least, and when checking less than, I need to go from least to greatest. Alright, now let's run our code. This is looking pretty nice. All I need now is to comment out this PE. Now before I turn in my code, I should get rid of any extra lines and make sure it's indented correctly and has the correct comments. Now if I wanted to clean up my main and maybe get a little extra credit, what I would do is take this code here and encapsulate it in a new function. If I'd like this function to return the correct string to be printed out, I'll have to change my code a little bit. Note that I'll have to pass in my PE so that I can check it here in my else if statements. I'll also need to pass in the house index. It's always a good idea not to do system out print lines inside of a function. Instead, return a string of the output you'd like to print out. That way, when you move to a GUI interface, it'll be easy to copy and paste this method to it and use it. Now it's yelling at me right now because the compiler is afraid that one of these else if statements might not be true. Now I know that if none of these are true, this has to be true. So I can comment out my last else if and just return that last string, which is our default if none of the other statements are true. Now we can use this method called getStatementAboutPE in our code instead of having that big blob of code inside of that for loop. Now instead of system out printlining what I had before, now I can system out printline my statement that I get back from this method. I'll have to pass to it the PE for our house and the appropriate index. Now our code will work as it did before, but my main is a lot neater. Great. So this is an even better way to solve a problem like this.